Hello students, today we're going to learn about the five main types of chemical reactions. So just as a quick review and goal setting, you should already know how to read a chemical equation. Today we're going to focus though on identifying five main different types by examining the chemical equations. I'm also going to be demoing these types of reactions for you as we go along. Okay, so the first type of reaction is called the synthesis reaction or the combination reaction. That's when you have two different compounds or elements coming together to make a new one. Okay, so you have here an example of solid magnesium, okay, which I will show you here in just a second, combining with oxygen gas to make magnesium oxide, which is a different solid. So what I'm going to do here is I have this solid piece of magnesium here, okay? I'm going to ignite it on a Bunsen burner that's off screen here, and I'm going to show you what it looks like. So first I'm going to put on my goggles here, because that magnesium is going to burn very, very, very bright, okay? And I'm going to use tongues here to grab the magnesium and light it. So here we go. It takes a few seconds for the end piece of the magnesium to reach the temperature that it needs to ignite, but we are almost there, and here we go. So that is magnesium burning, and it's very, very bright, so I'm not going to look at it. It's super bright, okay? But hopefully you can see now we have a white solid. Okay, so that's the magnesium oxide. See how easily it breaks off? It is a completely new compound with different properties. Okay, so again, synthesis. Two things coming together to make one. Now these are two elements. We can also have two compounds. So here we have calcium oxide combining with water to make calcium hydroxide. So it doesn't have to be just elements. It can be compounds as well. The next type of reaction that we learn about is the opposite of synthesis. It's when you have one breaking into two. Okay, so when one compound breaks into two or more substances. Again, this can be elements or compounds. So what we're going to do today is we have hydrogen peroxide. So here I have some hydrogen peroxide. It is a clear liquid and it naturally decomposes into water and oxygen gas. So if I let the hydrogen peroxide just sit here in the course of days and weeks, it will decompose into water and oxygen gas. But what I'm going to do is I'm going to use a catalyst to speed up the reaction, okay? And you're going to see the hydrogen peroxide decomposing right away. I am going to get a piece of wooden splint, okay? I'm going to light it, and I'm going to blow most of it out, just let like a little amber off on the side. I'm going to set my hydrogen peroxide going, and then I am going to put this wooden splint on the top of the beaker, just inside a little bit, not touching the liquid, but we should see the wooden splint relight. And that will be because the oxygen gas over here will be so dense that will cause the flame to just come back on in full force. Okay, so the first thing I'm going to do is I'm going to light my wooden splint, and then I'm going to blow it out in such a way that I still have um, just that kind of amber right there. And then I am going to get my catalyst, which is off screen here, but I'm going to put my catalyst in my hydrogen peroxide. So you can see the hydrogen peroxide bubbling right there. And I'm going to get my wooden splint and put it in there. And there it is, it relit. Okay, I'm going to do that again. So you see, it relights when it's in there because of the extra oxygen gas, okay, that is coming out right here. And you can see all those bubbles coming out. That's also the oxygen gas coming out. The reason why it looks black is because the catalyst that I use is black, okay? So that's not necessarily part of the reaction. That black solid is just making it happen faster. That's what a catalyst does. It speeds up the reaction, okay? So that's the example of the decomposition reaction when we have one thing breaking down into two. Now that I'm done with the flame, I'm going to take off my goggles. And we're going to move on to the next type of reaction, which is a single replacement reaction. That's when you have one element replacing a less reactive element in an ionic compound. So I am going to take a piece of copper foil, like aluminum foil, but copper, okay? And I'm going to put it in a solution of silver nitrate, which you can see is a clear solution. So what happens here is the copper is more reactive than this silver here. So it will kick silver out. And we're going to get pure silver and copper nitrate. Okay, so I'm going to put this in here. Now, it doesn't look like there's anything amazing, okay? And that's because this reaction happens slowly, all right? But if we let it sit over time, okay? So this is something that I did a while back, okay? I'm going to try to get it close so you can see. The copper that did not touch the solution is still there on top. You can see a little piece of copper foil, okay? But the one that was in solution, you see that gray kind of ugly sludge, okay? So that is silver, actually. That is pure silver that is coming out of the solution and turning into a solid. It is switching places with the copper. And the copper is going into the solution. And I know that the copper is going into the solution because if you look, that solution is kind of bluish, okay? This copper ion right here, copper 2 ion, it releases that blue color when it's in water, okay? So we can look at the original solution, which is clear, and then the solution after the reaction has happened after some time, and you see that bluish color. So you see that gray matter, that's the pure silver, and the bluish color is the copper nitrate that's in solution. So we got a single replacement. Copper replaced silver in the solution because it's more reactive, and we're getting the pure silver coming out. Okay, so that's pretty fun. And then our fourth reaction is, our double replacement reaction. Okay, so that's when we have two ionic compounds. They're both switch partners. Okay, so we're going to have lead nitrate and potassium iodide. So I'm going to mix these two liquids. Okay, so here I have potassium iodide. It's a clear liquid. And I have lead nitrate, okay, which is also a clear liquid. So I'm going to mix these two here. I'm just going to do a few drops. It may look a little bit magical, and then I'll explain what's happening. So when they mix, we get that bright yellow color. So it looks like they make a bright yellow liquid, but that's actually not what's happening, okay? What's happening is they make, which is even a little bit weirder, is they make a bright yellow solid. So we are mixing two liquids to make a bright yellow solid. So you see, I did this last night, and the liquid on top is still clear. And you see all that really, really fine solid that's on the bottom that's bright yellow, okay, because it sank overnight. It takes time because it's so fine, okay? It's sank over time to the bottom of the test tube. All right, so what happened in this reaction is the lead bonded with iodine, and it makes a solid right here. This is lead iodide, is that yellow precipitate, okay, the solid. And then the potassium bonds with the nitrate, and that's the clear solution that we see on top. All right, and then our final type of reaction is called an organic combustion reaction. So anything that's organic is something that's carbon-based. The skeleton of the molecule is based on carbon, okay? So we're going to have a hydrocarbon, which is any kind of molecule that's mostly hydrogen and carbon, and I have X's here because there's many different types, okay? So the number there can change. Burning in the presence of oxygen, making carbon dioxide and water. Okay, so I'm not going to demo for you because we already burned the wooden splint. Wood obviously comes from a living organism, so it's more of a mixture. It's not a single compound, but there's lots of organic compounds there. And when it was burning, it was making carbon dioxide and water, okay? And it uses oxygen gas, okay? So when we did the hydrogen peroxide, there was lots of oxygen gas, so it relit. So that was an example of a combustion reaction. Okay, so our 5 main types of reactions, okay? We had synthesis, 2 becoming 1. We had decomposition, which is the opposite of synthesis, 1 becoming 2. We had single replacement, 1 element that's more reactive replaces a less reactive element. We had organic we did have organic combustion, but we had double replacement, which is two ionic compound switching partners, and finally organic combustion, which is just an organic compound burning in the presence of oxygen.